I host. So there we go.
That's
Okay.
me. It is recording now. So
Okay. Oh, Paul.
Okay.
Good. All right.
Shall we start?
Yes, Sujiyama-san, please.
Okay. So before we go to the Horizon session of the, let me talk about briefly the MOU that the Linux Foundation and ION Global Forum signed. This slide shows that the ION conceptual overview and mapping the LF project. On the July 14th, ION Global Forum signed a MOU with the Linux Foundation covering the 3 projects: Open Programmable Infrastructure Project, LF Edge Feature Project, and LF Network Feature Project. Especially that the Open Programmable Infrastructure Project is our FDN scope area. Since we had a joint OPI session at the ION member meeting in New York, maybe some of you guys remember, in October last year, ION Global Forum member, especially the Reference Implementation Model Task Force and the POC Consultation Task Force, agreed for further collaboration through the OPI project that can cover the network use case, AI/ML use case, and the storage use case. ION stands for the Innovative Optical and Wireless Network. So probably you will feel that this will be relating to the all-photonic network evolution. It is true, but in addition, we are going to build a data-centric infrastructure in the middle of the computing architecture evolution. There are many traditional networks which are not friendly to transform to the data-centric that enterprise users need real-time memory access across edge and core and cloud for AI integrated communication business and cyber physical system, digital twin computing business, and metaverse business. So we are exploring for aggregating the many function dedicated network into DPU and IPU and transfer the user data directly to the user's application memory space, such as the GPU memory, FPGA memory, NVMe, and the person memory and DRAM, depending on the user's application use case. Here are our target function dedicated networks. I don't like to spend much time because we like to spend time to discuss the Horizon implementation status. So this time, Horizon of NTT Laboratory will talk about the UPF implementation status. So I like to hand over to the Horizon. And if you have any question about ION, please let me know offline, or maybe I can have another session to talk about ION POC project itself in other days.
Yes,
Yeah,
yes,
okay.
Sujiyama-san, we are planning to have another session specifically for ION.
Okay. Okay, so this time, Hirai-san, over to you.
Thank you for the thank you, Sugiyama-san. I am sharing my material. Can you see my material?
Yes.
Yeah, thank you. Again, thank you for inviting us to this meeting. Also, thank you for your interest in our activities. We are very glad to share our activities with you. Let me do my short introduction before I start my presentation. My name is Shiku Hirai. I'm a research engineer at NTT Network Service System Laboratories. Currently, my research activities focus on applying cloud-native technologies to commercial telecom networks and leveraging various hardware accelerators to enable high-performance network functions, as we will discuss today. Today, other member from NTT is Baba-san. He is my colleague. And our team's primary mission is to study the future network architecture of the NTT group. Okay, let me start my presentation. As you know, the discussions about 6G have begun in many countries around the world. The left diagram is sourced from a 6G white paper published by NextG Alliance, which promotes innovation with 6G in North America. And the right diagram is made by 6GIA, which is composed of European companies and research organizations. In both diagrams, the edge cloud is further broken down and it is named far edge, and indicating that computing resources are priced closer to the user devices. We are naturally thinking UPF to be deployed in this more distributed cloud environment. And we believe that offloading UPF onto a single smart NIC card, such as a DPU or IPU, allows for rapid deployment in such distributed cloud environment. This is the detail of the current our UPF implementation on DPU. We are using Bluefield 2 and running UPF agent on ARM cores as a container on Kubernetes. UPF agent communicates with 5GC using PFCP on the N4 interface as specified by 3GPP. In our test environment, 5GC runs on AWS and communicate with the UPF agent on premise side. 5GC was developed by our group company, NTT Technocross. So UPF agent was developed experimentally to connect with this 5GC. So there's no interoperability with other vendors 5GC. And based on the sample application for the DPI regex engine available in Docker, the DPDK RT flow API is used to add GTP encap and decap processing. And we have also implemented a QoS function that enables limited or guaranteed bitrate by using DPDK traffic metering function. If the hairpin queue is enabled, it is also possible to transfer the data back without passing through the DPI processing on the ARM cores. And this is the result of the QoS function verification. As shown in this table, 5 UEs were configured with different QoS parameters. And the upper right diagram shows the configuration of the measurement environment. We used 25 gigabit Ether Bluefield 2. We are waiting for the delivery of Bluefield 3 and will soon switch to using Bluefield 3. By changing to Bluefield 3, we believe our UPF can be applied to the large-scale use cases considered at this use case working group. As a traffic generator, we use PacketGen, which comes with DPDK. Since it is DPDK based, so a large number of host CPU cores are allocated. The figure below shows the results when TCP traffic is generated from each UE in the uplink direction. In particular, we confirmed that the bandwidth guarantee works as configured for UE1 and UE2, for which the GBR is configured. And here is the result for the downlink case. The same results as for the uplink case were confirmed. And this is a demo environment currently planned to utilize our UPF. We are considering an AI video analysis use case. In this demo environment, we want to exclude host CPU resources. We want to exclude host CPU resources from the user data transmission path as much as possible and achieve high-speed processing over end-to-end hardware acceleration. As this diagram shows, we would also like to verify that the same physical resources are shared among multiple applications. For example, sharing GPU resource for VLAN, DU, and video analytics workloads, and sharing DPU or IPU resources for UPF and media streaming functions. And for several options exist on the run side, including future plans. We have Fujitsu VLAN software using Area SDK developed by NTT Docomo's OREX. However, it is still too early to combine with this demo, so we are considering the other plan, such as Area Research Cloud. We are currently requesting NVIDIA regarding permission to use OAI node be combined with Area SDK. Otherwise, we also have other vendors' VLAN software, but not using GPU for 5G NR L1 processing. And also, Spirent runside is used as a testing emulator to connect to our UPF. Finally, this is the additional implementation plan for our UPF. Currently, the N6 interface protocol IP is specified by the 3GPP, but we'd like to try a non-IP transfer method experimentally. Mainly, we plan to implement a function to transfer the user payload directly to external devices such as GPU, FPGA, or other DPU or IPU. First, we are considering the case of Uplink. After GTP decap processing on UPF, the DPI engine is used to analyze the user payload. Then, based on the analyzed user payload type, the payload is transferred using DMA or RDMA to the appropriate destination device. We are considering DPI as one method of analyzing user payloads, but if there are other effective methods, we would be happy to discuss them. And we aim to exclude host CPU cores from data transfer route using DMA or RDMA. Basically, we are considering that intra-node transfer uses DMA or RDMA, and inter-node transfer uses Rocky V2. And we are currently investigating several libraries available in Docker. For example, UCX library, lower DMA or RDMA library, and RiverMax library. This is RTP use case specific. As I mentioned in the previous slide, we are also considering upgrading to Bluefield 3. We have confirmed that the ARM cores in Bluefield 2 do not perform well due to a bottleneck in DPI processing. So we would also like to see how much faster DPI processing can be achieved by switching to Bluefield 3. We would like to share our progress on this additional implementation at future meeting again, and would appreciate your feedback. That's all of my presentation. If you have any comments or questions, please ask me. Thank you.
So 2 questions. One is the Rocky on the DPU that's going to run across the cloud. I assume that the ION APN network can support sort of guaranteed delivery lossless streams, or does the DPU get some additional code for allowing, Rocky locally to run reliably over a metro or a wide area network?
Maybe let me answer from my side. ION has a technology about RDMA over all photon network, which is a long distance. Actually, we working progress. POC is working progress, but we see the good result. So worry about the distance, and we can guarantee that the quality for the RDM over all photon network. So Rocky is just Ethernet, RDM over converged Ethernet, just transit the Ethernet frame over the all photon network to the another DPU. Yeah.
Okay, right. So the network takes care of that part of the
Yes.
transport.
Yes.
Is there anything that you need to do on the DPU to facilitate that, or is it transparent because the APN ION network just handles that?
Yeah, transparency. So DPU just receive. It's a kind of just a local connection.
Yeah.
In same data center. We can try to expand the multiple data center over RDM over APN, but quality is similar to the local data center.
Right. Yeah, and then I think, I mean, I understand what this is trying to do. This is excellent. The two questions that would follow on would be, what could we get in OPI what would we need to do in OPI to support this, or what could be contributed that could become a common facility to make this open and standard, and then the ability to reapply reapply this for related contexts, right? Because you have a specific context in mind, but it'd be nice if we could then reapply the same approach based on the result of the POC in other contexts.
Should I answer? I mean,
Yeah, I'm saying, do you have any? Yeah, so what I'm asking, okay, so partly that was a statement and partly a question. The question part is, have you looked at what would be interesting to contribute, or what API you would want from the GPUs out of OPIs, because that'll help us, good use cases like this help us set direction.
Yeah, actually, this use case we try to terminate the user network packet inside the DPU and decouple that user's payload to the accelerator memory. So there is a mechanism is needed. Maybe we can use the DMA buffer to share the data. So we would like to discuss what technology is now available to store that data into the device memory.
Yeah, that makes, I got it. That's a good one. So basically a common way to build a local a DPU resident buffering or data store.
Yes.
To do the sharing.
Yeah, it's maybe that's kind of the storage use case, but yeah, we need a kind of technology to store the data in the memory. Yeah.
And that's beyond Rocky?
No, just actually, there are the two things that in this diagram. receive the data through the UPF, UPF decouple the GTP packet and send the user network packet. It's not enough. We need decouple the user's payload. Yeah. And the payload data should be stored into the target device memory, like a GPU memory or FPGA memory. That is the one thing. Another thing that once we receive the RDMA traffic at the remote DPU, the case that we would need similar thing that we need store the user's data to the maybe DRAM or NVMe, depending on the application use case. Yeah. So there are the two interface is needed. Two type of interface we can discuss. Yeah. But still relating the DMA. Yeah.
Yeah, we are considering the DPI engine is used to analyze the user payload. So based on the analyzed user payload type, yeah, the payload is transferred using DMA or RDMA to the appropriate destination.
Yeah, and
device.
another thing that once we store the data into the memory, the application needs to understand which memory space you are stored the payload data. Because the AI inference application running needs to know that which memory space you are stored the data. DPSF can decoupling, and maybe we can try to have the static memory space. I think that maybe compared to the current maybe GPU direct RDMA or GPU direct or DMA buffer, once the DPU or RDMA capable NIC receive the data that the information would be sent to the application, so the application can understand that which memory space you are stored the data. Based on that, application analyze the data.
I have a question. If you can go to slide number 4 or 5, maybe. Yeah, this one, or maybe slide 5. Actually, I'm sorry, slide 5. Yeah. No, not this. Slide number 5.
Number 5.
Yeah. Okay. Maybe I can speak to this one. So my question is that you did talk about some more advanced use case of processing or analyzing the user data. In this case, it was video stream and all inline in the DPUs. But the basic use case of DPU that you described, not in this slide, maybe go to the next slide probably, where you were showing the, I think this one. So in this, you were showing the what is happening in using the RTE flow that is leveraging the PDK based stack running on the ARM cores, and what is happening in the regex engine that was basically accelerating the DPI function. So would it be fair to say that the base part of your use case, if we don't go into the video, analysis of the data, the base part of the use case for at a minimum for UPF is to be able to implement RTE flow-based offload in DPU and DPI-based acceleration or DPI-based regex match engine on a DPU. Is that accurate? I'm trying to understand how do we wrap our mind around various use cases you have, and I'm trying to distill it down to the networking and the IO APIs that enables you to help with this use case. And then we'll get into the comment you made about allowing memory to be accessed by some kind of GPU device as well, or FPGA device separately.
Thank you for your question. Sorry, this demo environment, this UPF is just current implementation. So this UPF is role of GTP encapsulation or decapsulation and QoS.
Correct.
Yeah, only. So not including DPI engine.
Okay.
Function.
So this is that's why that you will need a back-to-back connection between UPF and the RTP decoupling function.
Got it.
But yes, IP connection between UPF and RTP decoupling
Connection.
Got it. So maybe we can go to the slide number 3, which was describing the I think it was this one. Yeah. So here you are describing that this is a UPF function that was shown in the other slide, right? Where you have GTP and basic things which are flow related things happening in the data path here, and the APIs to do the DPI is happening with help of ARM core and accelerators that exist out there in the DPU. Would it be worth standardizing these APIs in OPI for you to leverage a multi-vendor environment as opposed to what you have right now?
Okay.
So let me give you background for my question very quick. So at OPI, we are trying to standardize the DPU related APIs. So people who are using DPUs can switch between the DPU devices in order to keep their implementation consistent. Joe, correct me if I'm off here.
No, you're perfect, right?
Yeah.
Yeah, that's exactly right.
So in this case, what we are trying to understand from your use case is what kind of APIs that OPI can standardize on, so that you have choice of, not just DPUs, but, choice of hardware to be able to satisfy your use cases. And in that context, I was wondering if it is coming down to the APIs for in-cap, decap, for QoS, and for DPI, which currently in this example, you're showing that the in-cap, decap APIs are used with help of RTE flow-based offload, which is working off of a DPDK application running on ARM. And then some level of DPI to do regex matching on various things that are orchestrated through ARM cores, but implemented in accelerators in the DPU. And then for QoS, maybe we can define how hierarchical QoS looks like for UPF use case. But would it be fair to say that these 3 APIs, which is QoS, DPI, and the flow APIs, which is defined by PFCP and 4, sufficient for you to standardize in OPI?
So Vipin, allow me to try and answer that question a little bit differently.
Okay.
UPF has similar characteristics across UPF vendors, but not the same structure.
Mhm.
So in this specific case, NTT is talking about the distributed UPF, and as they mentioned, they made up their own. This is the NTT-TX UPF, distributed UPF. Now, if we at OPI want to create something generic that everybody can use, we need to think about exposing the attributes. So GTP and cap decap, QoS, and DPI separately as engines that could be then service chained in order to build your UPF agent. That would be probably the best thing we could do. And then each UPF vendor can go in and build their own little, Lego piece based on the Lego pieces that we just put out.
Yeah.
Does that make sense?
Oh, that makes total sense. I'm just getting exact same confirmation from NTT to understand if that kind of standardization would help. And you're spot on with respect to what level of APIs from the Lego blocks point of view that we need to consider. We have considered tunneling of various kinds. That is maybe not GTP, but it's okay. I think we understand the lowest part of it, which is GTP and traffic engineering or metering, because we have published similar kind of APIs for cloud use case. The part that is yet to be discussed heavily and I'm not saying that we have it all ready for UPF use case, but at least, we have considered tunneling quite heavily. We've considered metering quite a bit. But what we have not really talked about is the DPI level APIs so far. I mean, these are the Lego blocks, like you said. And I also understand the sentiment that things are moving to far edge, and it probably is not unique to this particular talk, because I've heard that moving UPF function to far edge is going to be likely as we go from 5G to 6G because of the speeds and latency requirements. And therefore, building these Lego blocks for DPUs to be prime for that segment would be ideal. At the same time, I think I'm getting a confirmation that if we were to standardize APIs for GTP, QoS, hierarchical QoS, and some level of DPI or regex matching, would that satisfy, or would that be appealing to this use case in NTT's mind?
Somebody from NTT want to answer that? Because on my end, I think the answer is yes, but NTT?
Okay, I would answer for that. Maybe, yeah. So standardizing the API in the DPU would help the vendor's implementation of the UPF, and also it will help us as well, because we want to put any multi-vendors UPF on multi-vendors DPU or IPU, these kind of things hard, and we would like to choose freely hardwares and softwares as operator. So generally, it will help the GTP and cap or the cap API, of course, and also the QoS things should be standardized. Will help us generally.
Okay.
Does it make sense?
Yeah, that makes sense. I think it makes sense. It'll be good if you could also comment on the DPI aspect of it. Does it have to be I mean, I understand you are using Doka, which is not really OPI APIs, but it's a good reference to look at for us to build some kind of API that is standard across multiple vendors. So for DPI, would you say that it would be just some level of regex engine that are exposed through the ARM cores, or does it need to be more than that? Like, maybe URL, URL parsing or more elements than that?
Yeah. And so when we talk about the ION use case, as Yamasan said, the behavior of the locky or memory access should be standardized because we are thinking the inter-cluster memory synchronization or data transfer with between the memories of the hardware. So that's our in ION related things to be standardized. And also, if you think about the 6G use case, the QoS API will be more important to make the low latency or deterministic communication in the mobile network. So if some hardware works very strict QoS assurance, but if other hardware doesn't work, that it will not good for us. So maybe those kind of QoS API and its behavior in the hardware is also important to standardize. That's from my side. Yep.
Guys, I have a question here. When we're talking about QoS, right? It seems to me that this is a scenario where we're talking about one network functions deployed on one network function deployed on the TPU, which is UPF, right? So where is the QoS policy enforced? Is it enforced at the infra level, or is it enforced by the UPF itself, which is the network functions? And if you're talking about UPF, then different UPF vendors would have different implementations. Similarly, at the infra level, in this case, we are using Docker, but of course, we could have a generic API instead of Docker. That's fine. But at the UPF level, that would be hard to achieve, right?
Why?
Well,
why is it hard to achieve at the UPF level? What is it? The implementations are too diverse? Is it just far too complex? And then kind of a level down from that. What is it?
yeah, I would think that, you know, the implementations would be too diverse, which means that essentially the vendors who are UPF vendors who are providing these network functions, they would have their own implementations, right? And their own APIs.
That's not exactly true. So if you are able, as I told Vipin, if you are able to provide the pieces, the blocks that they need to build a flow that breaks apart their internal UPF functions, then you are able to achieve offload. If you want to do the entire thing, it might be more challenging. But if you just want to accelerate an offload, if you break it apart into the basic pieces, I mean, obviously the easiest one is dispatch, right? When you start with dispatching the threads, you can use RSS. Everybody does that. Then you start breaking it apart to different types of, as they said on the slide, GTP, NCAP, DCAP, traffic metering. If we're able to provide a subset, or I would say expose an API for each and every one, then we'll give the tools to the UPF vendors. Most of them are very tech savvy, Ericsson, Nokia, NEC, and the like, to build their own structure on top of what we provide. I don't think that it's that difficult.
Okay.
So for NTT, how would you like to collaborate on this with, again, OPI is the Linux Foundation Industry Consortium. You can join at multiple levels, including not formally joining at all, but just having people participate and make proposals and submit code like you would for any open source project. Or you could join at another level if you liked. We can put you in touch with the right people for that very easily. But we would welcome just individual contributor level interaction as well, right? So if you wanted to work with us on defining APIs that would facilitate multiple DPU types being used in a common way, you know, we would definitely be very happy to work with you on that and incorporate that into OPI. Have you thought about this at all? And if you haven't, that's okay. You can think about it now and get back to us.
Maybe, yeah, I should answer. Yeah, and basically, we are happy to working with you in the OPI, but we are in the R&D department and making some codes for some prototyping, and yeah, so eventually we can share some codes with Linux Foundation, but I'm not sure if it's possible in our laboratories policy. But anyway, we will, or we can share the use cases with you to make our opinion or our business, or not business, but our future architecture happen and progress, and share our view with other company guys and the vendors using the DPU, because we see that these kind of the infrastructure things is important to provide the next generation network, and I think this working is important for us. Maybe we need to check that internally and get back to you later.
Yeah, and even if it was only like Vipin suggested, maybe we could start by defining a common DPI on DPU IPU API. So we say, here's what the, you could say, here's what the DPU IPU needs to provide from an interface for the DPI use case, part of the use case we have. And then we can collaborate on building that API, and then possibly even supplying code or saying how it maps in, each vendor can say how it maps into their SDK, which is, again, what we've been working on for several areas. And we start there, right? And then additional code or collaboration could come later. But, if we have any place to start, it moves the project forward.
Guys, if I may
Yeah,
direct your attention to a different fact. So can you please move to slide 6? Thank you. Now look at this map. There's so much we can do here. There's stuff that we've already done, like NVMe, that we're working on, but there's so much we can do here. Because all companies have in their portfolio either a GPU or an FPGA. And the request here to leverage GPU or FPGA for functionality, AI functionality mostly, but not only, I think that's another big piece that we should consider. Because while UPF is very good for telcos and for the Ericssons and Nokias of the world, it's more related to 6G, especially distributed UPF. Whereas stuff like being able to direct connect BPU, IPU to GPU and FPGA as far as memory dump is something which is hot right now and getting hotter by the minute, inference at the edge, right? So I would like us to think about other features as well, not only focus on the UPF side, but rather think about everything that we can contribute, because I think that one of the things we're trying to solve with this project is also multi-vendor for the green layer, not only for the blue layer.
Yeah, that's fair. How the DPU interacts with the GPU and what could we standardize there?
Yeah, it's either a GPU or an FPGA. So not everybody has a GPU. So to be fair to everybody, it's either a GPU or an FPGA. But yes, the idea is how to feed into an AI functionality as far as dump the memory, do not go through the host, or even do not go through the PCIe bus if possible. And how do we make sort of a transport engine from DPU to other devices, remote devices, or I should say local devices with a remote memory in a smooth fashion. I think that is a bigger problem, or to me at least a more general problem, because that relates not only to telco, but also to cloud, also to many other fields, retail, that would be interested, or general enterprise that would be interested in that functionality. Does that make sense?
Yeah, so it does to me. It's an excellent amplification, a lot. Hiroka-san, what do you think?
Yeah, I totally agree with that, and we also think, so today we have a talk about the UPF specifically, but as these diagrams shown, we are working on the hardware acceleration based on the GPU and DPU chain, multiple DPU, multiple accelerators. So and we are actually working on some application on that.
Yeah,
So,
we have
sorry,
another team doing the AI inference POC. It's also the same topic we are discussing about how we can transfer the GPU and FPGA. We say that accelerator device. Yeah. So I actually another team is still working on the ION POC. Maybe once we complete that, we can share that result, and we can exchange that idea furthermore about that how we can communicate the GPU and FPGA. Maybe we can think about the DMA buffer or others. So this is still ongoing. Discussion is still ongoing in the ION Global Forum side. Maybe we can exchange the idea each other later.
If I could just respond to Alad's comments, I think that's very interesting, Alad, but I think we've strayed considerably outside of the domain of what OPI is trying to solve. Right, you're talking about how do you orchestrate service chaining across multiple devices in a host, in a workflow. DPU is part of that, but really it's more about these agents and how they talk to each other and the messaging they use and how they access host memory. And that sort of is IP that's captured in those white boxes. And to me, the DPU is hosting that white box. Somebody's bringing that white box and using OPI APIs to access the DPU features. But what's in that box is not really an OPI thing, in my opinion.
I agree, Tim. So let me clarify. What I was talking about is the arrows in this diagram. We need to enable the arrows. And I was saying not only the arrow from the host to the UPF agent, but also the arrows from the IPU, DPU into vGPU, back again, and even into the other DPU, IPU sitting at the edge. So I was actually saying we need to do the API for the arrows.
And you view those as through memory rather than PCIe peer-to-peer or something like that?
So I'm saying that currently they're PCIe peer-to-peer, and we need to do better.
Yeah, the challenges with peer-to-peer is it's not as commonly used, and often there are performance shortcuts made in root ports that make peer-to-peer not be as performant as we would like.
Right, although speccing common APIs for code on a DPU to interact with a tightly coupled peripheral like a GPU or FPGA ought to be worth exploring. I mean, even if we don't try to solve the cluster of DPU, service chaining problem, although that is within our original scope.
Exactly.
It's just a bit harder problem to solve generically. Most people have done it very specifically, or they have massive toolkits that were developed over years to do sort of that service chaining, like telemetry has a couple or three of them. But those take a long time to mature.
As I see it, we have three levels of difficulty there. First level of difficulty is that NVMe over Rocky. implementation, which is DPU to DPU. Then it's the UPF and building the Lego blocks for the UPF. And finally, it's the arrows leading to the vGPU, and again, it could be an FPGA. Though that's the 3 levels of difficulties that I see, and we can select how deep down the rabbit hole we want to go.
I would agree, Alad. We have had no conversations about peer-to-peer interactions within the host between peripherals, involving the DPU, whether it's DPU to DPU or whether it's DPU to GPU, for instance, or FPGA. That's a gap, Joe, I think, where that's just something we haven't even delineated as we need to talk about.
Right. Yeah, so we should begin that. So Alad, how do you want to follow up on this? So I think if you summarized the main points and what the opportunities are, we could review that in the TSC. And then, so if the use case group laid that out and said, hey, here's some opportunities based on NTT, and here, NTT would like to collaborate on some of these, and sort of, join OPI. And then for NTT, if you could, maybe share this deck if possible. And then also if you could, here's what we would like to see in common across DPU, IPU vendors. Here's where we would benefit most from commonality. I think that would be beneficial, Hiroki-san. And then, like I said, if you could summarize, hey, here are the opportunities from the point of view of the use case group, including the one we were just discussing, then we can add to that and put some caveats or where things are easier or harder, and start to outline what the working groups would have to do to fully define or execute on that.
I would agree to that, Joe, with a small change, and the small change is priority from NTT. And maybe you said that and I missed it.
I did. Yeah, I said we'd like NTT to say, here's what we would like the most
yes.
from an OPI for open standards to use multiple DPU, IPU vendors.
Okay, so indeed. So what I'm suggesting is to the NTT team, please consider joining us. And hopefully once you join on one level or another, we can have a session in the use case group where you tell us what your priority is. And based on that, we can deliberate inside OPI and see how it fits into our POR.
Thanks, Joseph and Ella. Yeah, I'll talk internally about that and get back to you later with the priority and what we want to do in the use case working group. Is it okay for you?
I will just comment that Fujitsu has already joined. So we already have 3 of the 4 partners working on this.
Okay, thank you. Anyway, maybe we can join the call, and what we can in future we need to discuss it internally, but anyway, we can share our use case, including this UPF use case and other use case, such as I mentioned, the IPU, DPU interaction to other accelerators. So yeah, he hasn't anything to add.
At least we would like to share our progress on these slides, additional implementation at future meeting again, and would appreciate your feedback.
You're always welcome to come in and share. If there are no further questions, and let me pull for questions here. Anybody else? Any questions? Okay, if there are no further questions, I'd like to thank both Tsujiyama-san and the NTT team for joining us and sharing. Arigatou gozaimasu. And
Thank you very much.
we will definitely be in touch as far as next steps.
Okay,
Thank
thank you.
Okay,
Yeah.
Thank you so much.
Thank you.
Bye.